Good morning, my dear students. In this video presentation again, we'll discuss some more problems meant for class 12 of CBSE, which are very often tested in the board. The first problem meant for today, it goes like this. That A is equal to Z cross Z. Z is set of integers. Okay, now a relation R on A is defined as A comma B or C comma D if and only if A plus D is equal to B plus C. It is actually the elements in A will be as ordered pairs since it is given as Z cross Z. Okay, if that is a condition given to you, show that R is an equivalence relation. R is an equivalence relation. This is the question given to you. Okay, now while you think about the answer, A plus B is equal to B plus A. For any two A comma B element of Z, as addition is commutative. Addition is commutative in Z. If you add 4 plus 7 is same as 7 plus 4, but I should not give an example, I should give only a general possibility. Example should be done only to negate a statement. Okay, if you add any two integers, either way, write and add, it will give you the same answer. That is the meaning of commutative property. Therefore, A comma B or A comma B for any A comma B or every A comma B, either way you can write element of A. Therefore, I mean to say R is reflexive. This is the real meaning of reflexive property. Then let A comma B or C comma D, which will imply you A plus B is equal to B plus C, which will imply you B plus C is equal to A plus D. This will automatically imply you C plus B is equal to D plus A. The same reason. Addition is commutative. You can write the reason. Addition is commutative in Z. That's a condition which implies C comma D C comma D or A comma B. Reverse way it will be true. Reverse way it will be related. C comma D or A comma B. C comma D or A comma B. In the reverse way it will be related. Just see here, C plus B is equal to D plus A, which will be true. Therefore, this is the real meaning of symmetricity. Therefore, R is symmetric. Now, A comma B or C comma D and C comma D or U comma B, which will imply you A plus D is equal to B plus C and C plus B is equal to D plus U. You just name them as 1 and 2. 1 plus 2 will imply you A plus D plus C plus B is equal to B plus C plus D plus U. Here C gets cancelled, D gets cancelled, which will imply you A plus B is equal to B plus U, which implies A comma B or U comma B. Therefore, whenever A comma B related to C comma D related to U comma B will imply A comma B related to U comma B. This is true for any three A comma B, C comma D, U comma B element of A you can write. Therefore, R is transitive. Therefore, you can take down and write once again R is reflexive, symmetric, transitive. Therefore, R is an equivalence relation. R becomes an equivalence relation. After writing all the three again, therefore it becomes an equivalence relation. Let me just explain the whole lot. Just listen carefully. A plus B is equal to B plus A will be true because addition is commutative in Z. Therefore, A comma B will be related. Every element will be related to itself. A plus B is equal to B plus A will be true always. That is the real meaning of reflexive nature. If A comma B is related to C comma D, A plus D will be equal to B plus C. I can write B plus C is A plus D. I can write C plus B is equal to D plus A because addition is commutative. I can use commutativity in both LHS and RHS. Therefore, C comma D will be related to A comma B. C plus B is equal to D plus A. It's true. Therefore, this is the real meaning of symmetric nature. Then let A comma B related to C comma D related to U comma B. I mean to say A plus B is equal to B plus C, as well as C plus B is equal to D plus C. You name them as 1 and 2. And then just add. I mean to say A plus B plus C plus B is equal to B plus C plus D plus C. C gets cancelled, D gets cancelled. A plus B is equal to B plus C. So A comma B related to U comma B. Now A comma B related to C comma D, C comma D related to U comma B will give you A comma B related to U comma B. Therefore, this is the real meaning of or is transitive. Take down and write once again. Or is reflexive symmetric transitive. Therefore, or is an equivalent solution, from which I'll be able to get another result, for which I'll get the answer quickly and explain. Okay, the same thing what I'll do here is, instead of addition, I'll write it as multiplication. AD is equal to BC. Here I'll just write AB is equal to BA. AB is equal to BA will be true for any two A comma B. Here instead of addition, I'll write multiplication. I'll write multiplication is multiplication is commutative in Z. Okay, therefore here is the meaning of or is reflexive. Here instead of addition, I'll just write again AD is equal to BC. AD is equal to BC. Here I'll get BD is equal to AD. I'll write CB is equal to DA. Here instead of addition, I'll again write multiplication. Multiplication is commutative. Multiplication is commutative. Now for R is symmetric, I'll have here AD equal to BC, CB is equal to DU. Instead of addition, I'll just multiply the two results. Just listen carefully. Here I'll have AD is equal to BC, equation 1. Here I'll have CV is equal to DU. 1 into 2, let us say. I'll get AD into CV to be is equal to BC into DU. Here C gets cancelled, D gets cancelled, which implies AB is equal to BU, which implies A comma B or U comma B. Now for R is transitive. Now for you take down and write once again, or is reflexive symmetric transitive, therefore or is an equivalent solution. Let me just explain this part once again. I'll explain this whole part once again. Instead of addition, I'll have AD equal to BC, product of the extremes equal to product of the means. Now AB equal to BA will be true because multiplication is commutative inside. Now for A comma B relate to A comma B, for any A comma B or every A comma B you can write. Therefore or is reflexive. Here I'll have AD equal to BC. I'll write BC is equal to AD. I'll have CB is equal to DA. This is anyway equality. Remember carefully, this will be equal. Sorry, it looks like equal to. Okay, this will be equal. AD is equal to BC, therefore BC is equal to AD. Therefore I'll get CB is equal to DA. CB is equal to DA is the one to remember for, to recall that C comma D related to A comma B. The reverse way it is related. Now for R is symmetric. Let A comma B relate to C comma D related to U comma B. Here AD equal to BC. Similarly CB is equal to DU I'll get. In the previous case I would have added. Here I'll be multiplying. Now for AD into CV will be equal to BC into DU. Now for C gets cancelled, D gets cancelled. AB is equal to BU. This is nothing but equivalent to A comma B related to U comma B. AB is equal to BU. Check. Therefore A comma B related to C comma D. C comma D related to U comma B will imply U. A comma B related to U comma B. Therefore R is transitive. R is reflexive symmetric transitive. Therefore R is an equivalence relation. Therefore R is an equivalence relation. Okay, R is an equivalence relation. Now I'll just club these two and I'll give another result. Okay, club these two and give another result. That is also an equivalence relation. I'll do that particular problem also. Any of the three can be given in your board examination if you understand the rule behind each and every step over here. This is also an easier problem as in any other problem. Just listen carefully. Here A is equal to Z cross Z. R on A is such that A comma B or C comma D if and only if AD into B plus C will be equal to BC into A plus D. Show that R is an equivalence relation. R is an equivalence relation. This is what I am supposed to prove. Equivalence relation. Just listen carefully. Now AB into B plus A will be equal to BA into A plus B. Since addition comma multiplication both are commutative. Both are commutative in Z. Therefore, I can replace AB by BA, can replace B plus A by A plus B, which implies A comma B or A comma B for any or for every. Either way, I can write A comma B element of A. See here, AB into B plus A is equal to BA into A plus B. That is true. I can replace AB by BA, replace B plus A by A plus B. Now, therefore, this is the real meaning of R is reflexive. This is the real meaning of R is reflexive. Then let A comma B or C comma D. What happens whether I am able to get in the reverse way? This will give you AD into B plus C to B is equal to BC into A plus D. What I will do is I will write BC into A plus D here and I will bring this to the other side. AD into B plus C can be written as CB into D plus A to B is equal to DA into C plus B. The same reason I should write. Multiplication, addition, both are commutative. The same reason, let me write star here. The same reason I should write here. This is as equal as C comma D or A comma B. See here, CB into D plus A is equal to DA into C plus B. It is true. Therefore, R is, this is the real meaning of proving R is symmetric. Okay, let A comma B or C comma D and C comma D or U comma V, which will imply you AD into B plus C is equal to BC into A plus D, and also I will have, you will get CV into D plus U to B is equal to DU into C plus V. Now this will automatically imply you BC by BC, B plus C by BC is equal to A plus D by AD, and D plus U by DU will be equal to C plus V by CV, which will automatically imply you 1 by C plus 1 by B is equal to 1 by D plus 1 by A. Name this as equation 1. Similarly here, 1 by U plus 1 by D to B is equal to 1 by V plus 1 by C. Name this as 2. Now add 1 and 2. What do I get? 1 by C plus 1 by B plus 1 by U plus 1 by D to B is equal to 1 by D plus 1 by A plus 1 by V plus 1 by, what is this exactly? 1 by V, this is, 1 second, this happens to be C. 1 by C, just 1 second, this happens to be C, I'm sorry, this happens to be C. Therefore, here 1 by C gets cancelled and of course 1 by D gets cancelled. Take LCM, I mean to say U plus B by BU to B is equal to A plus V by AV can be written as AV into B plus U to B is equal to BU into A plus V. This is, let me just write here, this is equivalent to saying AB or UV. AV into B plus U to B is equal to BU into A plus B. Therefore, this is the real meaning of R is transitive. Therefore, take down and write all the three. R is reflexive, symmetric, transitive. Therefore, R is an equivalence relation. Only this part I will explain once again. This particular case I will explain once again. AB into B plus A will be equal to BA into A plus B. AB can be replaced by BA, B plus A can be replaced by A plus B. Therefore, R is reflexive. Write the reason. Addition, multiplication, both are commutative in Z. Here, ABCD or CD will give you AD into B plus is equal to BC into A plus D. I will bring this here, LHS or RHS, I will interchange. BC is equal to A plus is equal to AD into B plus C. I will replace BC by CB, I will replace A plus D by D plus A. AD by DA, B plus C by C plus B. Now, for I mean to say C comma D related to A comma B. The reverse way it will be related. CB into D plus A is equal to DA into C plus B to be proved. Our R is symmetric. Now here, this will imply you AD into B plus C is equal to BC into A plus D. This will give you CV into D plus U is equal to DU into C plus V. Now bring this BC down, bring this AD down. Bring this DU down, bring this CV down. Now for dividing individual by BC, I'll get 1 by C plus 1 by B. Here 1 by D plus 1 by A. Here 1 by u plus 1 by d. So 1 by v plus 1 by c here. Sorry, I rubbed it off, but I didn't write again. This is 1 by c. Just by adding both the results as it is, without interchanging LHS or RHS, 1 by c getting cancelled, 1 by d getting cancelled. After taking LCM, I'll get u plus b by bu is equal to a plus b by ab. Therefore, ab into b plus u to be equal to bu into a plus b is equivalent to ab related to u comma v. A comma b related to u comma b. ab into b plus u is equal to bu into a plus b. Therefore, it means R is transitive. R is reflexive symmetric transitive. Take down and write once again. It gives you R is an equivalent. Therefore, in just one video, I am able to get 3 different results which will be able to apply your mind in your board examination also. I'll check for the calculations again as usual. Then I'll upload accordingly. Thank you students for patient watching.